Today we're working on lesson 6.4, which is linear versus non-linear functions. So make sure that you have this title written at the top of your page. We're going to start off with some vocabulary. So we're going to go over those words linear and nonlinear, which I think that you've heard before. So linear, you guys have defined that as a straight line. I'm going to add to that definition, it's a consistent rate of change. So when we're talking about rate of change, we're talking about our slope. So it has a consistent slope. So in an equation form, it looks like this. We have our slope here and it's going up and over by the same amount. We have 1x. In a graph, it looks like this. It's a straight line and it's going up by 4, over by 2 every single time. For a nonlinear function, it does not have a consistent rate of change. So a function might look something like this. Notice how the x is squared. The two biggest things that you're going to see is a squared on the x or the x in the denominator. Either one of those is a nonlinear function. Graphs are easy to identify because it's just not going to be a straight line. So notice how this is a curved line. That means that it is nonlinear. So let's go over some tables. So I'm going to go over tables, graphs, and equations. So for a table, the rate of change must be consistent. Make sure x and y are going up or down by the same amount every time. So let's do this first problem here. So I'm going to see what my y is going up or down. In this case, it's going down, so it's a negative or subtracting 8. Let's see if it happens again. If I take 32 and I subtract 8, I'm going to end up with 24. So that's good. We're going to do it again. 24 subtract 8, and that does equal 16. So that y does go up by a consistent amount or down by a consistent amount. We're going to check our x now. There we go. So we're going from 3 to 6. That's an adding problem. 3 plus 3 is going to be 6. Let's check our next step. So 6 to 9. 6 plus 3 is 9, so that's good. That matches up. Now the next one, 9 plus 3 again. So that is consistent. Both of those are. So this one is linear. Now let's check this second table. So to have a consistent rate of change, it should be going up by the same amount every single time. So you can check your x's first or your y's, it doesn't matter. This one looks easy to check, so I'm going to check it first. 1 plus 2 gives me 3. Let's see if it's consistent or the same every time. 3 plus 2 is 5. 5 plus 2 is 7. So x goes up by a consistent amount. Let's check these y's now. I know that's an addition problem, and I'm going to be adding 9. 2 plus 9 is 11. Now I'm looking over here. How do I get from 11 to 33? I'm going to have to add 22. I see two different numbers here. Since it goes up by two different numbers, this is going to be a non-linear. Linear. Let's talk about graphs now. So if the graph is a straight line, it's linear. If it's not straight, then it's non-linear. So I'm looking at this first one over here. I'm asking myself, is that a straight line? And the answer is no, because it has that curve in it. That line actually bends. For this second problem, we are looking to see if it has a consistent rate of change. And this one is a straight line, so it is linear. Linear and non-linear. Linear, there we go, kind of. You know what I'm trying to say. So this one's non-linear, this one's linear. So now it's your turn. Does the table or graph represent a linear or non-linear function, and explain why? So pause the video and try those 3 problems. And here are your answers. So for number 1, we should have gotten that it was linear because the x's are going up by 7 and the y's are going down by 5 every single time. So since it's the same number on both sides, that means that it's going to be linear. Same thing for number 2, it is linear. X is going up by 2 every time, y is going down by 4 every time. And then number 3 is actually non-linear because it is not a completely straight line. So there is a bend at y equals 2. So since it has that bend in it, even if it's not a like curvy bend, it's still considered non-linear. So now we're going to talk about equations. The thing to look out for is if you can rewrite the equation in the form y equals mx plus b, it's going to be linear. Nonlinear, first get y by itself. The 2 biggest things to look out for is when the function is nonlinear, there's going to be exponents on the variable or an x in the denominator, which we kind of talked about earlier. So what I mean by exponents on the variable is going to look like y equals x squared. So since it has that square on the x, that means that it is nonlinear. And then x in the denominator, if it says like y equals 2 over x plus 7, since that x is in the denominator, it is nonlinear as well. And those are going to be the 2 cases that you see as 8th graders. So now I have 4 equations for you here. The question is, which represents a nonlinear function? So we have y equals 4.7. You're asking yourself 2 questions. Is there an exponent on the variable? In this case, no. Y doesn't have an exponent and there's no x over here. And then is there an x in the denominator? No, there's not. So this one's good to go. Let's look at B. Y equals pi x. Again, ask yourself the 2 questions. Does the variable have an exponent? Nope, it doesn't. Is the x in the denominator? Nope, there's no denominators. So that one is good to go. Now we look at C. Is there an exponent on the variable? Nope. Is the x in a denominator? In this case, yeah, it is. So C is going to represent a nonlinear function. Just for fun, let's check that 4th equation out. So this one looks a little bit different, but we can distribute that 4. Ooh, I don't know why it's messing up so much. We can distribute that 4 to everything that's inside of our parentheses, and we end up with an equation that looks like this. Sorry, that is really rough. So y equals 4x minus 4. That is in the form y equals mx plus b. So that is going to be linear as well. And again, there's no variables on the exponent and no variables in the denominator. So now it's your turn. Do questions 4, 5, and 6 and tell me if they're linear or nonlinear. And tell me why. Pause the video if you haven't done that already. And here are your 3 answers. So for question 4, it is linear because it's in the form y equals mx plus b. Number 5 is also linear because it is in the form y equals mx plus b. And if you can't see that form, I did it for you over here. So we can move that x down next to that fraction instead of up there. And then I can always add a plus 0, and that's going to be my b. Our last one, problem 6, is going to be nonlinear because x has an exponent. So x to the second, or x squared, is going to represent a nonlinear function. Only thing left to do now is your homework. So do problems 5 through 10, and then 12, 13, 14.